doesn't even need an introduction because most of you probably know who he is or have seen him at different events around the Northeast Kingdom. But we are so fortunate and so excited to have Bobby Farlice-Rubio here with us today. Bobby is going to take us out of the darkness and into the light and kind of give us a little bit of perspective on the historical myths and legends around solar eclipses. Back in the times when people, it got dark in the middle of the day and people didn't really understand why, and they had all sorts of interesting theories of what was happening. So just a little bit about Bobby, for those of you who might not know him. Bobby has been a science and culture educator in Vermont's Northeast Kingdom for nearly 2 decades now, with his teaching experience. He's been a familiar face at the Fairbanks Museum, as well as many other Northeast Kingdom venues. He's taught for 18 years at the Fairbanks Museum and Planetarium. And one event that I remember especially was an event that he hosted, which was the Guinness World Record largest astronomy lesson. And I happened to be there that day. Main Street, I think, was closed off, Bobby, correct, and Church Street, and it was really a wonderful event. Bobby can be seen, or could be seen regularly, on WCAX Evening News with his monthly Starstruck segment, so probably some of you have seen that. He's also a regular contributor to Danville's newspaper, the North Star Monthly, with his column, Consider This. Bobby was raised in Hialeah, Florida, of Cuban and African-American roots, and he is an avid musician. Some of you may have heard his wonderful group, Tritium Well, and then his latest solo endeavor, Bobby and the Isotopes. During the summer, you can find Bobby at Stillwater Campground out in Groton State Forest as a park ranger. And most currently, Bobby serves in the House of Representatives over in Montpelier as the Caledonia 1 District Representative for Waterford, Reigate, and Barnet. So, without any further ado, thank you so much, Bobby. We're so excited to have you here.
Well, thank you, Patty. Thank you, everyone. It's a great pleasure to be here and not talking about politics and not, talking about the beautiful things in the sky. And it looks like the weather forecast could not be better for April in Vermont. You don't expect to have the sun that we're going to get for this eclipse. I hope all of you have plans to see it from a safe location and don't plan on getting out of town anytime soon afterwards. Just maybe bring a cooler full of food and snacks and water in your car, so if you're going somewhere, so you don't have to rush. But I'm going to be tomorrow driving right into the Lion's Den of the city of Burlington. I'm going to be on the stage on the waterfront with Channel 3 News. So just so you know, you can actually live stream my commentary from 3 to 4, even on the website. So if you have your phone with me, you might have me, guiding you as to what's going on in the sky. And full confession, I have never seen a total solar eclipse myself. So I may get too emotional. I don't know what's going to happen. But I'm expecting a lot. And so, there's a lot of things I want to talk about, a little bit of just preparation. You probably have heard a lot about it. But I also want to give you some of the coolest things that we have done in history with solar eclipses and how they've influenced even the ancient past. So we're going to talk about a lot of different topics, and I want to open it up to questions. So I'll pause a few times during the presentation to see if anybody has a question, and I hope that you feel free to ask me anything you'd like. So right here on the screen is a free program called Stellarium, and you may have seen me tinkering a minute ago, setting the latitude and longitude for exactly where we are, and I dialed it in for tomorrow. You can get this on a website called stellarium.org. It's totally free, and if you look at it carefully, you might recognize it's made by the same company that made the Fairbanks Museum's digital planetarium software. So it has a lot of the same graphics and same use, but you can use it at home. And because I made it tomorrow, and it's exactly this time, 1:10, you might notice, of course, you go blind. I don't need to repeat that you need to wear glasses when you look at the sun. Please don't stare at it. But in this program, it's safe. You can see the moon right there. That's how close it's going to be before the eclipse even begins. And with this program, we can zoom right in. and see what's going to happen. It's sort of a dress rehearsal, a simulation. And as I advance the clock, we'll see exactly what Danville's version of the eclipse is going to look like. I'm going to slow it down for dramatic effect here. But so before it gets all the way to total eclipse, that's a partial eclipse. And some version of that is going to be visible to almost all of the continent of North America, all the way down to Central America. So a lot of the world will get to see a partial eclipse. But it'll dim the light a little bit. It won't have the astounding effect that you would get from the totality. But anywhere where there's a partial eclipse, or tomorrow before the totality occurs, you can make some really fun projections of something like that with this, or a colander, or anything you have in your house that has a lot of holes drilled into it. If you hold, I mean, I could do it now, but outside you would just see a lot of little circles, and you might just think those circles are just because of the shape of this, but actually they're projections of the sun. So when the moon is partly in front of the sun, those little circles will be little, well, like Patty's cookies over here. And I gotta point out, if you hadn't seen them, yes, she went through the trouble. I almost lost a tumble, but yes, all of those cookies, you're gonna see hundreds or dozens of those little images projected depending on what state the moon and the sun are in. So that's a fun way if you're, out there looking for something to do while you're waiting for totality. And you can also, if you don't even have a colander, there's a trick, and I'll show you a demonstration later, that you can use your fingers to do the same thing. If you put your fingers just the right distance so you get little pinhole-sized gaps between them, when you hold that out in the sun, you can see your shadow, and you'll see little crescent-shaped eclipse projections. So, fun thing to do, but I think the big show, the reason why people are driving from hundreds of miles away, including my brother who's here, he came all the way from Miami to see this with his two friends. His name's Dylan, and Dabney and Mark are next to him. So, it's worth it, folks. Don't miss out. People are driving from hundreds or thousands of miles away. This is totality. This is the big show that everyone is coming to see. It's hard to compare that to just a partial eclipse. I was here in 2017 when St. Johnsbury had something like this, and we still had 1,000 people show up at the Fairbanks Museum just for that. So just imagine, it's totally worth it to see this. And I'll explain what we're actually seeing. And there's something you may have heard, and I just want to confirm this to people so that everybody is safe. But you can actually take off your glasses during this part of the eclipse. The sky will be dark and the sun will be blocked, but depending on where you are, it's only going to be less than around 2 minutes. As soon as the light brightens again, you want to pop your glasses back on, look away, and then protect your eyes. But during totality, it's actually safe to look at the sun, because if you leave your glasses on, you'll miss your chance to see this, the corona of the sun. And this is just a simulation, but all kinds of things can be happening on the sun. I'll even show you a website where you can see what the sun is doing on that day, and you can get a prediction of what kind of flares or prominences, or if we're really lucky, like winning the lottery, a coronal mass ejection could be happening that would look like an explosion coming off the surface of the sun. So that's totality. Lasts a couple minutes, and then, depending on where you are, and then the sun slides off, but you have to put your glasses back on at that moment when the sunlight reappears. And so, right at the beginning and at the end of totality is one of the stranger things that's still not fully explained by scientists today that occurs, and maybe you've heard about it. Has anyone heard? There's actually a story on NPR just this morning about shadow bands. And I've been looking into this. It's one of the things that people have told me about an eclipse that I'm hoping to see. It's not always obvious, but we might be lucky that there's snow on the ground, because it provides a nice bright projector screen for this phenomenon, which is where right when this happens, somebody has described it as slithering snake shadows. Or one of my colleagues that went to Wyoming to see the 2017 eclipse she said it looked like the land turned into water, where everything was shimmering. And I have found a video of someone who took it. It doesn't ever reproduce on video as well as it looks to your eyes. But NASA is actually trying to study it with this eclipse to see if they can get a determination to what actually causes it. Some people say it's the atmosphere, the way the light bends. Think of how, you know, on a hot day in the summer, it looks like there's water shimmering over the road. Could it be that? Or could it be light polarization? Or something more subtle? We're not sure, which is kind of cool because solar eclipses have led to a lot of different scientific discoveries. In a little while, I'll show you how the solar eclipse in 1919 helped confirm Einstein's theory of relativity. So that, you know, solar eclipses still have knowledge to yield to us. We haven't figured everything out yet, and solar eclipses provide us the unique opportunity to see things as they otherwise never appear. So maybe I'll stop for just a moment because maybe some of you were surprised to hear that you can look at the total eclipse without your glasses. It's just that it's dangerous right before and right after. And there's something else that can occur right at the moment of eclipse that you want to have your glasses on, but they call it Bailey's beads. And I'm trying to simulate it here, although I have a better video of it. You can almost see how some of the light looks like it's turning into dots. And then there's something else that I'll show you a video of called the diamond ring effect, where that last piece of the sun that's still visible shines like a gem, and it looks like a diamond ring floating in the sky. So, anybody have any questions so far? Yes?
Is it safe to be without glasses to see the beads?
No, you can see the beads with the glasses on, but that's just about the last thing, and the diamond ring effect. Before that happens, it kind of set it up just like that. So the contrast in light will be dramatic. I mean, you won't really have to guess because you'll see the landscape suddenly go dark, and the temperature might drop, especially if it's dry like it is right now with low humidity. It might drop by up to 15 degrees. So you won't, even if you're not paying attention, you're going to notice something happen. You'll be like, whoa, and it might be warm. I mean, today in the sun, it feels really great. And tomorrow's forecast is up into 60 degrees. So a drop from, let's say it's 60 to drop to 45, you're going to notice that instantly. And just because what has happened is that the shadow of the moon has caught up with you. And you may have seen a video that I had playing a little while ago, but that shadow is moving at 3,000 miles an hour. But it's basically got a pocket of cold air that's following it as it goes across the landscape. So it's sort of like almost like a kind of a windstorm that's very unique. They can't be created in any other way. So any other questions before I move on in this program? I can send Patty the links. It's stellarium.org, easy to find online, works on every kind of computer, and you can do all kinds of fun things with it too. Maybe we have time later. I can show you, like where this is happening relative to the constellations. So I'm sorry if you thought you were in Aries, but actually the sun is still in Pisces right now. And it will be there, all those dates. If you read the North Star Monthly, my first article was all about debunking astrology and horoscopes. So I'm sorry if you take that stuff seriously. You're going to hate me over that. So anyway, let me move on. I'll leave stellarium alone and talk about some other things.
So what was those little circles that were circling the sun in that picture?
Oh, the dot. Those are just that's stellarium's way of targeting something. Like when you select something, that's how you know what you've got selected. You see, it's sort of like that's what you've picked to study in the program. It's not, if that's in the sky, we're going to be talking about aliens, So here's a really cool website, the greatamericaneclipse.com. They have pages for every state, but they have this really great animation of the shadow moving across the landscape where it tells you the size of the shadow, the speed, and the duration of totality for that particular location and the timing. And it's very accurate. And I just want to mention that this graphic up here might remind you, you may have heard that part of the country got to see a different kind of eclipse just last fall in October, an annular solar eclipse. Now, this is an interesting thing to think about because an annular eclipse is when the moon is a little bit farther away than average. The moon's distance to the Earth is not a fixed number. The orbit that the moon takes around the Earth is elliptical. So it has an apogee when it can be far away. It's about 20,000 miles, almost 30,000 miles farther away than when it's in perigee, when it's closest. And whether it's a full moon or a new moon changes from month to month. Forgive me, but I wish we called them months, and then everybody would understand these cycles more easily. But so when there's an apogee, when the moon is far from the Earth, and there's an eclipse, it can't block the whole sun. The moon is simply too small, and some of the sunlight appears around it, and that's what we call an annular eclipse. Annular, like the word annual, meaning a ring, in Spanish, I grew up speaking Spanish, anillo is a ring. I'm not wearing any rings, but so if you think of it, it looks like a ring of fire in the sky. But a solar eclipse that's total has to happen when the moon is a little bit closer than the apogee, and we happen to have a very close near perigee moon when this is happening. So the shadow, in 2017, the shadow was about 70 miles wide. This year, it's going to be about 100 miles wide just because of that change of distance. So it's a little fact to consider. And I'll put this up just real big so we can see if we can track our part of Vermont as it goes by. I'll just point it out. There's the Canadian border. It's going to repeat. There's New Hampshire and Maine. So when it starts over, you'll see there's Burlington. Middlebury's at the southern edge. There's St. Johnsbury. So you can see that Danville on Route 2 is not in the center of the path, but well within the path of totality. So this, you can watch this all day long, but don't miss the real thing. So let's see. Here's a map. That website is a great resource too for people who are curious about where it's going to be happening. This gives you the lines that tells you how long you're going to get, and you can see that Danville's just around the 2-minute mark here. So, any other questions? Yeah.
You said during totality you didn't need the glasses. Can you take a picture with your phone without a filter?
Yes, you can, because the light is significantly dimmer. But just be careful that as soon as the totality ends, that light could damage your phone. I mean, you're able to handle it for a flash, but you don't want to be doing that. But I've heard of people, I may try it, using these on their camera lenses, because the phone camera lenses are tiny. And you can actually probably get a decent picture, or at least something, when it's not totality with these glasses. Although, photographers and professionals get these very expensive filters that allow them to do that. And I do know that Channel 3 has one of those on the roof of their station for tomorrow. So there's going to be some footage, and if you miss it, you'll be able to watch it for all time online after the fact, which is a nice thing about living in the world we live in today. If you miss it, somebody will have taken a picture of it and will have it online in seconds after the fact. So I actually told them to set up a camera to catch the shadow bands, and I should show you a picture of that, because it's not a myth, it's not, but it is magical. Here's an old engraving of that. So it's just when totality is about to occur, you might see the landscape or the buildings get covered in these moving shadows. It's not a very good picture, but here's somebody who some photography of that from 2001. So it's not something that picks up well on camera, but you're going to want to be looking for it, especially if you're next to a snowy field. The ground might just look like it turns into water. So let's see. Let's move along now. So just a couple of things that I mentioned. It's a little embarrassing but fun thing to say. I can show you the picture later, but I had my first ever resolution read out on the State House floor on Friday. A House concurrent resolution when we commemorate something cool. Sometimes it's an athlete getting a trophy. Sometimes it's the birthday of a famous Vermonter in history. But this time I commemorated a syzygy. Have you heard that word before? You'll win Scrabble every time if you learn it. S-Y-Z-Y-G-Y.
Oh my gosh.
Yes. 3 Y's and a Z? Yeah. So that word is an ancient Greek word that refers to the alignment of 3 bodies, in just the perfect way. And that's exactly what a solar eclipse is. So I don't know if it's true or not, but I think I had the clerk of the House read the word syzygy for the first time in the history of the Vermont State House. And it also commemorated the Fairbanks Museum in its role for educating the public on this event. So it's on the record, and Mark Breen was graciously there in person to accept the resolution right after it was read. So I gave him a copy, and it'll be at the Fairbanks Museum. And another copy will be sent to the University of Vermont, which has the NASA Space Grant Consortium that funds a lot of the educational programs around the state related to astronomy. So kind of a nice little historical footnote there. But the syzygy that I had commemorated, this is what it actually is in this little animation when these 3 bodies line up just right. And I'm going to pause this for a second because this shows you the continental view of what's going to be happening tomorrow. That's the shadow of the moon. But this big circle is everyone who might see partial solar eclipse. So a huge swath, all of North America practically will see that partial solar eclipse. But look at the select few, the lucky people that live on that line. That's roughly 100 miles wide, and we're right on it. So that's what's happening tomorrow from a bigger perspective. And there's a couple of this video, NASA made this, and it has a couple of little highlights of some of the things that I talked about, like the diamond ring effect. They have a good simulation here. Did you see that? I'll back it up. That will be the last thing you see that you need to have your glasses on for, and then you can take them off. So here's another show, and there's that diamond ring effect, and it's right at the end of that the Bailey's beads phenomenon may occur. It's not guaranteed, but I think it's thought to be the sunlight peeking through the rims of the craters on that particular part of the moon. It's like a jagged landscape, even though it looks smooth. It's a bumpy surface. So let me just show you one other thing. Hold on, I should go back to that because it'll illustrate some of the things I talked about. So, and I can take questions throughout. I'm just gonna advance this real quick.
So earlier you were mentioning shadow banning, like the effects.
Yeah.
Just before totality.
And at the end too, it's like a bookend on both sides.
What physically causes that?
I think you may have walked in right before I explained it, but we don't know. That's the cool thing about it. We're still at a loss as to how to fully explain it. And so
Estimates as to what it could be?
it could be an atmospheric distortion because it could be the temperature change. You remember that 15-degree drop, you have air of different density, and that could be bending the light, which would be a sort of Earth-based explanation. Or there could be a space-based explanation, meaning that the light that's coming around the edge of the moon has been polarized. And I mean, I could spend a whole hour just talking about what that means, light polarization. But if you ever use polarized glasses, a lot of people like them because they can see through water. The sunlight is generally not polarized because the sun's light is coming from all different angles and directions. But when it gets bounced off of a flat surface like water, it becomes polarized. All the light is sort of marching together in the same line, to make a simple explanation. And that, when the moon covers the sun, you're getting such a limited window into the sunlight that it might kind of create a giant polarizing filter with the moon. That's just a hypothesis. We haven't been able to confirm any of that. Maybe the scientists will tell us what it really is by, Tuesday. I don't know. I'm sure it'll take a while for them to crunch the numbers. But yes, this is going to be everyone in Vermont, I hope, with their glasses on safely, except for that one kid who didn't listen. And he didn't want, the ophthalmologist will be seeing him soon. And this is a photograph. I didn't make this picture, but this is exactly why I have this here. So just a reminder, one of the things you can do, and if you don't even have one of these steamers or a colander, your fingers will do it. And we're not in the time, this is a telescope projection of an eclipse, and I did something like that at the Fairbanks Museum in 2017, but I used one of our wonderful Galileo scopes that we used to sell in the gift shop, which is made out of plastic, which is just fine, except that halfway through the day I started smelling something funny coming from the telescope, and then I popped it open and the plastic on the inside was starting to melt. So don't ever look at the sun with a telescope. It will destroy your eye instantly. But even Galileo himself in 1610 figured out that you could point a telescope at the sun and it becomes a projector. And you can lay out a piece of paper, something bright, and see exactly what is going on. But I don't recommend that unless you have a lot of experience with using telescopes. Now, this is something that happens more easily with deciduous trees, and it's too early in spring for us to have leaves on the trees, but it's possible to work with a balsam fir, spruce, a pine, any evergreen tree. The same effect as your fingers and the steamer, you get these little tiny projections of the eclipse when it's partial. So it's just something fun to look for, because you're going to have about an hour to see the partial part before the total clip. So while you're out there looking at the environment, I'm going to highly recommend people be observant, because this is actually part of the lore of solar eclipses, is that animals are said to act strangely. And I've heard stories, but I've never witnessed it myself. But we have migratory birds coming in. I've been hearing red-winged blackbirds and pine siskins and all that. They might start singing their dawn chorus at that moment because they don't know what time it is, and they're like, "Wait, is it dawn again?" And so you might hear that. Yes.
Is there a concern for like dogs?
Like, are they likely to look up?
Dogs generally, most animals are smarter than us when it comes to things like this, and they don't look at the sun anyway. Yeah, they won't look at it, but I've heard that dogs start barking or howling, or coyotes might start howling depending on where you are. I met a gentleman who's no longer with us, who was a dairy farmer in the 1932 solar eclipse, which is the last time, but that was in August when cows would be out in pasture. Right now, nobody's pasturing their cows yet, but apparently the cows stampeded down thunderously to the barn, freaking out, like not knowing what time it was, or maybe expecting their grain or to get milked in the middle of the afternoon. So the animals all act strangely because there's no reason for animals to have an instinct about eclipses. They're so rare that it's not something that any animal would have any kind of instinctual awareness of. So it's just like,
not looking at the sun.
yeah, and they generally don't anyway. It's only us that are like, what's going on? We go against our instincts all the time. I mean, it's part of what being human is, I guess. But yes, I wouldn't worry about the animals, except that I would observe them. I would see if you have cats or dogs, pay special attention to them, and maybe you might help us add to the volume of science related to animal behavior during eclipses. But anyway, but yeah, I'm really going to be curious because it's spring with the birds. I think everybody's going to notice that. If it was the middle of summer, people say the crickets start chirping for the totality because they don't know what time it is either. But it's too early for crickets. Maybe we'll hear some peepers with this weather. I don't know. That would be fun. That's my latest article in the North Star, by the way, all about peepers. So I just want to feature something very cool because this is something that is now possible that only generations ago would have dreamed of. This group of kids from California in 2017, they're an after-school math club. They did an amazing feat, and I'm sure they're going to do it again this time. But they launched a weather balloon with video cameras and a parachute and GPS trackers to see what the eclipse looks like from above. And they timed it just right, and I'll show you real quick what they did in a little summary. So they went to Oregon from their home base in California because that was where the path of totality was back then. So they launched their balloon up into the sky, and minutes later, it was 100,000 feet up. And they could see the shadow approaching. That is the eclipse shadow racing across the landscape. 70 miles wide that year, but I want to mention this is one of the things that I'm grateful to be in Burlington for because we have 12-mile wide Lake Champlain and the Adirondack Mountains. Although it's going to be going 3,000 miles an hour, it's possible that like the shadow of an owl swooping down on a poor little rodent, you might see that shadow hit the mountains and swoop across the lake. So they're going to have cameras set up to see if they can capture that, but this is from up 100,000 feet. And this camera did get enshrouded by this shadow, as you'll know, there. And you can kind of get the idea of what the difference is between like south of Middlebury and in Barnett, that it's going to be sunny. And then right here or St. Jay and Danville, it'll be really dark. And then after that, the shadow raced on, left the picture. You can see the sun re-emerging on the top of the image there. And then the balloon popped, as they always do when it gets that high up. So it takes them days to find it because they have to wait till it parachutes down and it might be miles away from where they launched it. And then they use their GPS tracking devices to figure out where it is. So you'll see the shredded balloon pieces at the top of the image there. And there it goes, back down to Earth. So there, and then they put an image of the path of totality from that particular eclipse. But some of the fun things that can be done during an eclipse. And, just for reference here, I'm going to put on a fun video. This is the whole year's moon phases. So just to be clear, eclipses of the sun, a solar eclipse can only happen when there's a new moon because that's when the sun and the moon are in the same direction. And I wasn't planning on talking much about it, but of course there are the other eclipses called the lunar eclipses, which are much more common and happen only during a full moon. And the reason why they're not as special, I think they're special, but the reason why they're not as rare and they're not as hard to see is that when a full moon lunar eclipse happens, everybody on that half of the world can see it at the same time. You don't have to be in the particular path of totality. It's like half the world can see it, and they happen about once or twice a year. So, but the next solar eclipse that's going to happen in Vermont will be in 2079, and it's only going to cover the little southeastern corner near Brattleboro. So we'd have to drive a long distance, and I'll be 100 years old. So I have hopes try to eat a healthy diet. Maybe I'll make it to that one, but I'm not taking it for granted. So I'm considering this my only chance to see one in Vermont. But of course, they happen all around the world. Here's a solar eclipse corona picture that was taken in 2016 in Indonesia. Your eyes may not be as sensitive enough as the camera to see this, but this gives you an idea of what could be happening on the sun on any given day. And in addition to these beautiful streaks of light, you see these strange loop shapes. I'll talk about what causes that in a moment. And then even this thing that looks like a volcanic eruption, that's a prominence. That could be happening. Just like weather, there's no predicting on precisely when those things will occur. So we could all be surprised by the sun's own weather. And I just want to show you what the sun is all really about. Since we're talking about removing it from the picture, we have a new observatory on Mount Haleakala in Maui. It's the National Solar Observatory. It's named after the former senator from Hawaii, Daniuke Inouye. And it is the biggest eye on the sun that we have. And this is the surface of the sun every day. And I'm just going to zoom in on this same video. These bubbles that are moving around, emerging like a simmering stew, each one of those bubbles is the size of North America. That's how big the sun is. And this is just the very surface of the sun, even when it's not stormy. And you can see that the photospheres, we call it, the part that gives off the most light, there's layers just below that are even brighter and even hotter, and some of that light is peeping through the cracks between those big bubbling cells. And so that is what the sun is doing all the time, and that's the observatory that was able to make those images. And being on the ground, it's easier to build a giant telescope that can do this, but some of the most interesting telescopes we have in the sky looking at the sun are actually in space. There's just a little comparison. There's the Inouye Solar Telescope, 13 feet wide. But those little ones over there that are just, 5 inches wide, you don't need a huge mirror to look at the sun. The sun is huge. But the one over there, SOHO and SDO, which is 8 inches wide, can have produced things. The SDO has made videos like this. This is what the sun is doing up there. And you can see some of those were in that image I showed you, like that eruption. And the sun, these are different wavelengths. So this is not exactly the same light we see with our eyes. Some of these are X-ray, some of these are ultraviolet images of the sun. But that allows us to see different layers and to see what's going on below and above the surface. This is actually close to what our eyes see. And you probably heard of sunspots. Those sunspots, each of them are bigger than planet Earth. And they're storms. They're basically like a hurricane, like a cyclone. You could even see that they're spinning. And the reason why they're dark is because the plasma that would be where that dark spot is has been removed by the magnetic fields that emerge. So it's kind of getting cooled, relatively speaking. The coldest part of the sun is 11,000 degrees Fahrenheit. So there's nothing cold up there. But it's a little bit colder in that spot, so it's a little darker. And what's happening is the magnetic field that connects those different sunspots is looping plasma away. And when you saw those loops that appeared in those images, they often start and end in these sunspots. So they're all connected. Sunspots were discovered by Chinese astronomers over 1,000 years ago. There's a legend that says that they were ordered by their emperor to stare at the sun, to do exactly what we've been telling you not to do all this time. So if you don't listen to all the warnings on the radio and on TV and here today, you will have one gift. You will be able to see sunspots with your naked eye, but you won't see anything else. That'll be the end of your normal vision, but you'll at least be able to count sunspots. I don't know. It's not a good trade in my mind, but that is how they were first discovered. So there are just a couple more things. They're sort of the greatest hits from the early days of the Solar Dynamics Observatory. And I do want to mention just one more thing that can happen. So you see those magnetic field loops that connect, those would be sunspots in a different wavelength. You can see that the hot stuff is floating above the surface, being taken out of what would be a dark spot to our eyes. So maybe I'll pause after this because I'm sure this is going to spawn a lot of interesting questions.
Isn't this a particularly active time?
Yes, the sunspot cycles, well, that's a tongue twister. They follow an 11-year cycle, and we're getting near the peak. So that means that there's more of this happening than on average. And especially like during 2000, oh, see that right there? Look at the plasma raining back down, splashing when it hits the the surface. Those are what people call solar flares, and sometimes a coronal mass ejection, even bigger. And I don't want to open another can of worms, but when those occur, they affect satellites. They can shut down electronics. They can cause blackouts. Like Canada one time had a huge province-wide blackout in Quebec because of one of those. It's basically like getting zapped. With a coronal, well, a solar flare, a coronal mass ejection is just a technical term for what people call solar flare. Solar flare sounds a lot better, rolls off the tongue a lot easier. But a coronal mass ejection, there are different classes of them. And the highest classes, X-class solar flares, are the ones that can, well, I wouldn't say harm human health, but affect the human world in very great ways. If you're in an airplane flying over the Arctic when one of those happens, you actually get a significant increase in the radiation that you're exposed to. And they try to redirect flights around that when that's happening. And it causes, the everyday kind of solar activity causes the auroras. So just think about that the sun is 93 million miles away, but little, pops and eruptions on its surface cause electrical activity in our atmosphere. That's what the polar bears and the penguins are seeing on the either ends of the world. So I could spend all day talking about the sun, of course, here he goes, but I want to cover some other topics while we're here. But this is just a little diagram of all the stuff I was referring to. Yeah.
How tall are those above the surface of the sun?
Thousands of miles.
Thousands of miles.
Most of the ones that you saw in those images would be bigger than the Earth. Like if we superimpose the Earth, going back to that video, the Earth would be smaller than my fist in this picture. So you can just get an idea. Planet swallowing storms, if you wanted to write it in a dramatic way. Yeah, maybe if we get to the end, I can talk about what happened in 1859.
Well, now that you said that, we have to know that.
Oh, okay. I guess I did open the can of worms. So I'll put this back on for just a moment, but also, yes. So this is sometimes called the Carrington event because of a British man named Carrington who was observing the sun. He had a cool device called the heliostat that projected live images of the sun onto the floor of his parlor in England. And so he would lay out pieces of paper and draw the sunspots of the day, and he actually created pretty good scientific data. But while he was doing this, one of those sunspots became so bright that it washed out the whole image that he had of the sun. And so he, said that was cool. He wrote it down in his notebook. In 1859, I think it was September 1st, 1859. So nobody at that time thought it was a big deal except for the handful of people who were studying sunspots. But that evening, 18 hours later, all around the world in the tropics, like in Havana, Cuba, the sky started glowing with auroras that most people in the tropics had never even heard of before. Like northern lights for the world, not just for the Arctic. And everybody was like, this is so amazing, or is it the end of the world? Maybe we should go to church. I don't know. There were a lot of reactions that people had to seeing this for the first time. But there was a group of people at that time, probably that numbered in the hundreds or maybe 1,000 people in the world that were telegraph operators. 1859, just imagine, electronics didn't exist except for telegraph machines. And these systems were new. They were just being installed in many places. And they had short runs between cities like, Baltimore and DC and New York and Boston. They were just getting deployed. There was no grid, so they were all run by battery power, locally, connected at the terminals at the different stations. And all of a sudden, the telegraph operators, in some cases, their wires started bursting into flame. And they were like, what's going on? And they disconnected the batteries. Some of them, the little tap keys started going off on their own with nobody touching them. Like, they were like, what is happening? I don't know. I just got trained last week. I've never seen this before. And so they started sending messages without power. They're like, this is Boston transmitting. Like, are you reading? And, New York would respond, yes, we're reading. We have no power, and we're still able to transmit. Like, how is this happening? Nobody knew. So basically, they had to rebuild some of the transmission lines. I mean, you see those lines along the railroad that still have those glass insulators. I mean, I think maybe they realized those glass insulators were part of that, like as a solution to prevent fires from occurring, because the wires on the wood would have gotten so hot that they could have set some of those towers on fire. So anyway, this was a thing. At that time, nobody understood that was connected to what Mr. Carrington saw on his paper, but eventually scientists realized that this was all one phenomenon, the sun having a big eruption on us. And so if the next question you have is, what would happen if that happened today? These little things that we carry in our pockets would be no better than a ceramic tile to make a nice countertop in your kitchen because they would stop working, not because they're dead or damaged, but because every chip inside of them would be fried by that amount of electricity. Well, these won't, but some things might. And none of our cars, not just electric cars, even all of our internal combustion engine cars, none of them would work because all the microchips and all the electronics in them would be fried. The military knows that this can happen, and they have designed equipment that can survive this kind of an electrical event. But most of us don't have that kind of stuff at home. So I jokingly say that everybody would become Amish for just a while until we can rebuild the infrastructure to get our electronics back. So anyway, so there you go. I tried to do that as quickly as possible, but that's just something that the sun can do, but not just directly connected to an eclipse. But let's talk another scientific discovery that I mentioned earlier. It's known as the Eddington experiment, and this is just an illustration of what was done in 1919. Relatively recently, we had photography. They took a picture of the sun, and you can see that one of those really cool prominences was happening during that time. But what you see in the background is the location of stars in the constellation Taurus in their labels. And Albert Einstein, in his theory of relativity, proposed that gravity can bend the direction of light. This is a hard thing to prove, especially in that era. So they figured out that during a solar eclipse, they might be able to prove that by being able to photograph stars in the same direction as the sun, stars that were already mapped and known. We knew how far apart they looked in our pictures. So you go out there, take pictures of that part of the sky before the sun is there, then wait till there's an eclipse, and then look at what the stars look like they're doing during the eclipse, and it confirmed that Einstein was right. The stars looked like they had moved, not because they had, but because the gravity of the sun was changing the direction that the stars appeared to be in. Here's a real simplified diagram right here. You could never do this without a solar eclipse because the sun is too bright and you wouldn't be able to see the stars behind it. But if the star is actually there on the bottom, the gravity of the sun will distort it and make it look like it had moved, just as the sun was sliding in front. So that is a very real scientific discovery. And, you know, the theory of relativity, when it first came out, would have sounded hard to believe for a lot of people, because but now we take this for granted, and we use gravitational lensing, which is what now astronomers call it, to discover new things. We've actually discovered the oldest known star by using the gravity of another object in the foreground to bend the light and sort of magnify something that would be too distant for us to see with normal telescopes. And they named that star Arundel, which is an ancient Old English word which means morning star. Not because it's like the star of morning like Venus, but because it's like from the early days of the universe. This star that we've now photographed would have been shining when the universe was less than 1 billion years old, and now the universe is 14 billion years old. So this cool effect that Einstein helped us discover, eclipses helped us confirm, literally is helping us discover new things that would have been impossible without the concept. So now let's talk about a very different time in history. This is an illustration from the website of the Onondaga Nation. And I don't know how much you folks know about Native Indigenous history in America, but you may remember learning about the Iroquois Confederacy back in your history books. That word, Iroquois, is not the word they used to describe themselves. They prefer the word Haudenosaunee, which means the people of the Longhouse. And I'm talking about historically 5, now 6 nations, but originally 5 nations that live in the upstate New York region along the Finger Lakes area. And the ones that are closest to Vermont and closest to our indigenous Abenaki people are the Mohawk Nation. Everybody's heard of the Mohawk Nation and their very cool hairstyle that was named after them. But this is really cool to me because this is where something that might have been dismissed as myth or lore can be confirmed with science and take something that was a mythical concept and made it real. So the Haudenosaunee people, a long time ago, in their own folklore, over 1,000 years ago, were in a period of great warfare with each other. And I'm talking about the Mohawk Nation, the Seneca, the Cayuga, the Oneida, and the Onondaga Nation. They were in a period of constant back and forth warfare, assassinations, kidnappings, and it was terrible. And at that time, there was one particularly warlike chief named Tadodaho, who seemed to relish this time of war and never wanted it to end. And according to the legends, looks like Medusa perhaps, that he had snakes in his hair. That's who's in the foreground of this picture too. I don't know if that's literally true, but maybe he had unkept hair, maybe he had locks in his hair or something that made him look really strange. But he was supposedly crooked in the way he walked, and he was just like a wicked man, evil by every description. And he loved this warfare. But there was another man named Hiawatha, or Hiawatha, but not related to the Longfellow poem of the same name, but this man was a chief that wanted to bring about peace. And he met with a person that in the Haudenosaunee language is called the Ganawida, which means the peacemaker. And the peacemaker was thought to have come from a different nation. They said he spoke with a funny accent or with a speech impediment. He wasn't a local. He wasn't native to one of those nations. But he observed what was going on, and he told Hiawatha, this is nuts. You guys are going to kill yourselves. You're going to wipe yourselves off the map if you keep this up. You have to find a way to bring peace. And so Hiawatha said, I don't know how to do this. So he went to the different chiefs of the different nations and tried to persuade them to bring about peace. And something happened when he went to the leaders of the Seneca nation and went to their council longhouse. He said, you must look to the sky to tell you if we need peace. And at that moment, there was a total solar eclipse. And the Seneca people were like, okay, we're on board. Something's going on here. Let's sign up to this idea of peace. And Tarodaho was the one that resisted the most. And there's a particularly grisly part of the story where Tarodaho heard the case that Hiawatha was making for him and said, okay, you want peace? Sure. And while he was in conversation with Hiawatha, Tarodaho whispered to some of his warriors, basically hitmen, sent them to the other village where Hiawatha was from and had him kill his wife and children. And then while Hiawatha was there, was getting ready to leave, he found out what happened. And he goes, now do you still want peace? And that's an amazing point in history because Hiawatha said, even now, after having lost everything, I still think that peace is the right way to go. And so there's different versions of this story. I've heard from other sources, the Onondaga Nation says it was the Seneca that saw the solar eclipse. But the other version that I remember hearing first was that eclipse actually happened when Tarodaho raised his club and he was going to hit Hiawatha on the head, like to end this conversation about peace. And when he saw the solar eclipse, he dropped his club and said, okay, I'm on board. And he made a couple of sort of requirements if he was going to go along with peace. His nation, the Onondaga, would be the hosts to the councils that would unite the different nations together. So we had to be the capital, is basically what he said, the Onondaga Nation. And everybody who is the leader of this, I'm going to be the first leader. I'll be the speaker of the house, so to speak. And everybody who comes after me in this will have my name, Tarodaho. So there have been 167 Tarodahos since this occurred. And I have a website from Tarodaho Hill today. It has been there since 2002. You can see if I can pull up the picture of this gentleman who's the current Tarodaho. His name is Sid Hill, but that's his official title. And he's been doing it since 2002. And so because of all of the calamities and all the trouble that happened since the European arrival and the conquest and the genocide and the plagues that wiped out 90% of the population, the date of this event had been lost to history. But they did know exactly how many Tarodahos had been appointed over the years. And they did some analysis based on how long people who have lifetime appointments serve on average. Think of like kings or Supreme Court justices. Do a little math. If you have this many people doing that, how long ago? And it was close to 1,000 years. And then it turns out that on August 22nd, 1142, there was a total solar eclipse that went right over that same part of New York State. And so now we have the exact day of what was referred to in those stories. And so that means that the Haudenosaunee law of peace, and this is actually probably the most famous image. You may have even seen it on bumper stickers. It's called the Hiawatha Wampum. That was made to commemorate this understanding, this peace. And that pine tree in the center actually refers to something that is the end of that story is after the agreements were made, they took a young white pine tree and they uprooted it, and they took all their weapons of war and threw it into the hole where that tree had been growing, and then they replaced it and put it right back in the hole. And that's actually where the reference to burying your hatchet comes from. That's where that term comes from, referring to this particular. They literally put their war hatchets in a hole under the tree and said, we don't need these anymore. I'm going to lay down my sword and shield, right under the pine tree. So now, just a little thing about wampum. When I was a kid, I was told that that was money, but that's actually not money. It's actually sort of like an unbreakable message. And they're made out of quahog shells, which they're not quahogs anywhere near that part of New York and Canada. But this is just a sign of the difficulty of making these. People would go to the coast and trade with the folks on the coast of Maine, like the Wabanaki nations, and get quahog shells, and then spend weeks or months polishing and cutting the little parts of the shells to make the beads. And eventually, this kind of technology was replaced by, the glass beads that were brought by European traders later on. And this is why the beadwork concept is an ancient concept in Native American cultures, but today they're made with more modern, less difficult materials than quahog shells. So I think it's a really fascinating thing because, if you study the Great Law of Peace, it's considered to be the longest continuous government in the world because they still have their regular meetings in Onondaga region of New York along the Finger Lakes, and they still have the Taro Daho. And what I remember reading about the time around the American Revolution, Benjamin Franklin and Thomas Jefferson met with some of the leaders of the Mohawk Nation and heard about this, and it inspired them to create a representative form of government that's a little different from the parliament that England has. So the Speaker of the House that we have in the House of Representatives is modeled after the Taro Daho, and every nation or every state sending their representatives to a central council fire in D.C., for what it's worth right now. Whether or not they're getting anything done is a different question. But that whole idea, and the Mohawk Nation is still invited at the convocation of every new Congress after they come in January after the elections. The Mohawk leaders come and do a prayer and sort of start things off for that reason. So, our nation's form of government was inspired directly by this.
Is it physically in a museum somewhere?
Yes, I don't know exactly where, but yes, that does exist. And there are, there are replicas of it, but that's the original one on the Onondaga Nation website. I wish I knew exactly where it was. I didn't get that detail, but I could probably find it for you. But, so, 1142, a government that has stood that long. So, I guess we're running low on time. It's almost 2 o'clock, but let me see if there's any other questions that you folks might have. Oh, and according to the story, Taro Daho's hair straightened out and he became upright and all the snakes fell out of his head. So, there's that.
They could have been dreads.
Yeah, that's what I thought. I always thought, he may have just had this appearance to make himself scary for, similar to Blackbeard, who used to put slow matches in his hair and had an unkempt beard, and he would raid ships, he would light them on fire, so he had smoke coming out of his face. So, hey, it works. Psychological operations, they call it in the military. So, any questions, though, folks? So, solar eclipses, they're not just a weird thing that happens in the sky. They literally change the course of history on this continent and around the world. Oh, that's all right. Good timing. So, anybody have any other questions?
Are there other significant historical events that line up with the told solar eclipse, such as the moment when they were advocating for peace?
Like this, I don't know any story that so perfectly aligns with an eclipse like this, where it changed the course of events. But I can imagine that every time they happen, up until the modern era of astronomy, when we had the mathematics to calculate this, it just caught people by surprise. And in this case, it was perfectly timed to bring about an end to warfare. Maybe we can hope that that'll happen tomorrow. Wouldn't that be the best thing that could happen tomorrow? So let me know if there's any questions. I'll stick around for a while if anybody wants to ask away. Let's see if I had any other cool pictures to show you. Oh, well, maybe we'll end on a sort of a beautiful, inspiring note. about the celestial mechanics, the big picture. And as this go back to the program I had loaded up before, Stellarium. There it is after the eclipse. But to kind of get the idea of what it took our ancestors, thousands of years of observation to understand, in this program, you can make it happen in a matter of seconds or minutes. So if you, I almost forgot to tell you, during totality, you're going to be able to see planet Venus and planet Jupiter, and some of the stars of Orion, like Betelgeuse possibly, or in Sirius, the brightest star in the sky. I know you're not going to want to look away during totality, but if you scan the horizon, you're going to see some of the stars and planets in the sky too, which is another beautiful thing. Just imagine, this is what led folks to understand some of the things that we call like the horoscope or the ecliptic. Notice that Venus and Jupiter and the Sun make this nice little line. That's not a coincidence. That's kind of how it always works. And if I put up those constellations, you might notice that Venus is right under one of the fish of Pisces on the tail of Cetus the whale, and Jupiter's over by the hooves of Aries close to the bull, Taurus. And that's why people put such stock into those constellations, because the planets, the moon, and the sun are always amongst one of those 12 zodiac constellations. And let me just show you what Stellarium can help you understand, because this concept can get a little wonky for folks. But if you turn off the ground and the cardinal directions and put yourself in outer space, maybe like those kids in California, if you were riding on that balloon and you could see all of this, and then you would understand what's going on. There's Taurus if you recognize the constellation. But let's see, I want to reduce too many distractions on there. So now let's put this in motion before my computer's CPU melts down. The moon is moving around, and I jokingly talked about a month. The moon cycle repeats every 29 and a half days. So in this, when I speed up time, every time you see the moon sail by, you'll just know a month has passed, roughly. And if I go a little faster, there goes the moon. Goodbye, see you next month. Notice the planets. They're moving on their own time scales, too. That red one must be angry. It must be the god of war, Mars. The radiant one must be the goddess of love. She's so beautiful. And this must be the king. Only second in brightness to the goddess of love. Oh, and here comes the moon again. So you get an idea of how long this would take to observe. And then if I speed up even more, you'll get to see the dance of the planets. But people noticed this long before they understood the planets were going around the sun and that we were one of the planets. It took Galileo's telescope to make us realize that we too are on one of these platforms that's moving around the sun. Those look like little race cars going around the racetrack. And eventually, with the telescope, we were able to deduce their orbits, like Mercury and Venus, which are always closer to the sun than we are. So they never seem to leave the sun's environment. They're always hanging out in the mornings or the evenings, but you never see them in the middle of the night. And there goes the moon, keeps going around. And you might notice some of the planets are drifting slowly, like over here, like Jupiter and Saturn. They move much more slowly than the others. It takes Jupiter 12 years to go around the sun, and Saturn nearly 30 years to go around the sun. So they have their own mind, their own schedules. And that's what the Greek word planet comes from. It didn't used to mean a world. The word planet came from the Greek word planetes, which meant hobo, vagabond, traveler. So it was the word, and the word plane, like terraplane, aeroplane, also comes from that. It's a traveler. And they realized that those things were different from the stars. In fact, I know the two of the planets' names in the Abenaki language. Venus was called Masatwa, and Mars was called Masingwa. And Masingwa is actually a character in Abenaki mythology. Is a warrior that wears a red mask that protects humanity from monsters like the creature that is said to lurk in Lake Champlain. And this is pretty cool. Here, let me pause this for just a second. Oh, look, there's Taylor Swift. No, that's the constellation Virgo. She hasn't gotten her own constellation yet, but maybe someday. So let me put up the label here so you can see the planet names, and then you see Mars over here. Now, as we go through time, I'm going to pause when we get to the Scorpion constellation. You see Mars go right by the claws of the Scorpion? Okay, so that happens roughly every 2 years. But I'm going to see if I can zoom in on that for a second. The constellation of the Scorpion comes to us from the Egyptians and the Babylonians, filtered through the Greeks and the Romans. But the Abenaki people have always seen a very different constellation in that same group of stars. And I'm using the word constellation sort of loosely here. But if I take away the image there and you look at the star pattern there, in the Abenaki language, that group of stars is called Gitaskog, which means the serpent with horns. And that's actually the Abenaki name for Champ, the monster from Lake Champlain. And so if you were looking at the sky through the Abenaki lens, you would see that red-faced warrior go through the head and horns of that monster every 2 years as if they were doing battle in the sky. And so the legend and the stars match up very perfectly. And it's difficult to see this constellation completely from this part of Vermont because we have so many hills and trees, and this constellation is always low on the horizon. But I've always heard that you had to go to the lake to see the lake monster and the stars. And one year I was on South Hero Island for the 4th of July, and I remembered this, and I ran out to the beach on the southern point of the island just at the middle of the night, and there was the Green Mountains were on the left, the Adirondacks were on the right, and framed perfectly by the mountains was the whole creature with his tail just above the water. And I was like, so you really had to go to the lake to see the lake monster and the stars? And I was just like, it's true. So there is another, indigenous lesson, and I always wish we had better connection with these stories because that's the bits and pieces that I've been able to find out there. But as you may have heard me say, after European folks arrived in North America, there was a 90% population drop from all the diseases that were brought in. This happened as recently as the 20th century in the Amazon. There's still uncontacted tribes in the Amazon, and they are very wary of outsiders because in the 20th century, Portuguese missionaries came into parts of Brazil, and they also saw 90% of their people just drop dead from diseases that, think of the people who came on those ships from Europe. They grew up in cities in the 1500s and 1600s that had open sewers. People had smallpox, diphtheria, yellow fever. Like if you know the history of Philadelphia, how many people died there. But if you were an adult from Europe on a ship, that meant that you survived all of that. And most of your brothers and sisters would have died while they were toddlers as you were growing up. So that was people who had been run through the sieve of disease coming to a place that had never seen any of those viruses at the same time. It's one of my favorite quotes that from a history book. It's just like, imagine if the Black Plague and Genghis Khan arrived in Europe at the same time. We'd all be speaking an Asian language right now. So just the facts of history. So I'm going off topic here. I'm going far ranging. I think we're going to wrap it up unless anybody has any other questions. But
Bobby, thank you so much. Really we had some solar eclipse
we're gonna
glasses
take a
on
picture.
your chairs, so don't forget to wear those tomorrow. And just a little reminder that we are the Danville Historical Society.